All right, we're going to start on our next unit. We only got 2 more units to squeeze in here. This one's going to be very short. It's only going to be 4 lessons, so I'm going to start with 2 lessons this week. And most of the questions we're going to do some textbook stuff, okay? So this unit's called Sequence and Series. It's one of the chapters in your textbook near the back. And it's basically about number patterns, okay? And we use these kinds of number patterns to create more complex formulas. A lot of financial formulas are created from this, formulas that repeat, even some of your exponential formulas you've seen. So let's move in and start checking this out. All right, so part 1 here, we're going to talk about what are called arithmetic sequences. Okay, so now there are sequences in series, and we're going to just focus on arithmetic sequences today, and then the next lesson will be arithmetic series, and then or geometric sequences, sorry. Anyways, just back to arithmetic for now. So what is a sequence? A sequence is just an ordered list of numbers, right? So I've got a sequence down here, right? Just an ordered list of numbers. They're in order, and it's a list. Pretty simple, right? Now, the big first thing we got to know today is what makes it arithmetic, all right, or arithmetic, right? That is when the sequence has a common difference. When we say common difference in math, that means a pattern that we're generally adding or subtracting. Now, really we say adding because you could be adding a negative number, which is the same as subtracting, right? But that's what we got to know. When we say the word common difference, that's important, okay? So what's the common difference in this pattern here, right? What are we changing by each time, right? Pretty simple. We're adding by 5. Adding by 5. So you can find the common difference, no matter how complex it is, by taking any number in the sequence and subtracting the previous number. So 7 minus 2 is 5. 12 minus 7 is 5. 17 minus 12 is 5. Okay? All right, so that's what makes it arithmetic. We're adding by 5 each time. All right, so I'm going to move on, and we're going to look at some different formulas we can do with this. Okay, so here we are. I'm going to look at the same sequence of numbers here, and we're going to define 2 types of formulas first. The first formula is called the general term, okay? So the general term is basically this. T stands for term, okay? And N in subscript written below is the term number, okay? So in this case, we'd say Tn is the nth term in the sequence, okay? So let's talk about what that means by looking at the sequence here, okay? This would be T1, T2, T3, T4, T5, term 1, 2, 3, 4, and 5, right? So when we say Tn, that could represent any term, right? N depending on the term number. Okay, so N is the index or the term number. Okay, now what else do we have to define here? We have to define some important stuff for our formula. Okay, so again, let's just focus on this general term formula for now. Okay, so when you say, you're going to see a lot of stuff in the textbook that says use the general term or what's the general term. This is what we're talking about, this formula right here. Okay, so first thing, we've identified, what T is, what N is. A in our formula is really important because A is the first term in the formula. So that's this right here. A is the first term. So we always have to identify that. So where does our list of numbers, our sequence, start at, right? It starts at 2. So that's what A is. All right, the next thing we need to identify is D. D is the common difference. And we already kind of identified that a minute ago. What are we changing by each time? So what are we adding by, or are we adding a negative number, essentially subtracting? So we already identified, right? Remember how we were adding 5 each time. That is the common difference, okay? And so on and so forth. All right, so D is positive 5. So just be careful, because if it's a negative, you want to make it negative, obviously. All right, so let's go through some kind of examples here for this one, some basics, right? So the first thing, A says, determine the general term. So I'm looking at A down here. So I'm just going to move this page up. Sorry, I got to kind of move around to fit everything in here. You can kind of copy stuff on your note as you see fit. All right, so let's do A. What is the general term? Well, we're going to take this formula right here, and we're just going to fill in A and D. So let's just replace in that formula, okay? So Tn, the general term, is A, the starting term, 2, plus n minus 1 times D. Now notice we're not replacing n, because n will represent the term number when we're actually using this and solving and using it for some things, okay? So what we want to do is simplify this. So 5 times n, 5 times 1, so I have 2 plus 5n minus 5, and now we can just clean it up and make it into 5n, and the 2 minus 5 becomes negative 3. There is what we call my general term. So I can use this to find any term in the sequence. 5 times the term number minus 3. Okay, so determine the third term. Now we already know the third term, so let me just move this back up here. We already know the third term is right here at 12, right? But it's always good to test your formula out on something that you know for sure. So let's do that. I'll just do part B over here. All right, determine the third term. So what we do is we're going to take Tn, and we're going to replace the n, right, in our formula with 3. And we're going to replace the n here also with 3. So 5 times 3 minus 3, well, obviously 5 times 3 is 15. 15 minus 3 is 12. It worked. That's what we wanted to get, right? Term 3 is 12. Perfect. So it's always good to test it out, make sure it works on something that, you know, we're sure about the number. All right, determine the 25th term. Let's do part C here. All right, term 25. Well, T25 is 5 times 25 minus 3. All right, so I'm really squishing it in here. So what's 5 times 25? 125. 125 minus 3 would be 122. So if we wanted to find, you know, that term, there we go. So we can use these formulas to find other terms in the sequence. Now, here's where it gets not a little tricky, but the next step, I suppose. What is the term number for the value 512? So what they're saying to me here is, what if we gave you 512, right? That is one of the terms, right? Like 2 is a term, 7 is a term, 12 is a term, 17. So eventually we would get to 512, right? What's its term number? So what is the n for that, right? That's what we're looking for. So let me just move this down here. All right, give myself some room. All right, so for part D, what we want to do is we are going to set, right? Set Tn equal to 512, and we're going to solve for n, okay? So let's take that formula there. Tn equals 5n minus 3, right? Let me just write it down here. I guess it's right above, we can see it. And we're going to set the term itself equal to 512. And then we just solve for n. So it actually is really simple. This is like a grade 9, you know, 2-step problem. What are we going to do? We're going to add 3 to both sides, right? And then we're going to divide both sides by 5. And that's going to give us n. So 512 plus 3 is 515. And 15 divided by 5 is 103. So just to be clear, what does that mean? That means therefore, just want to be clear to you, the 103rd term, right, in this sequence is 512. All right, there you go. Okay, so there's the basics of it. Now, the next thing we got to talk about is what's called the recursive formula. Now, the general term formula is the most important. Like if you had to pick, the general term is 9 out of 10 of importance, and the recursive formula is the other 1 out of 10, okay? The recursive formula also seems to cause the most confusion. Pretty much everything you do is with the general term, but I just want to show you the recursive formula because it's important. For those of you taking recursion or taking computer science, you might know a bit about recursion already. The recursive formula is more of just showing and demonstrating what the pattern is. It's actually broken into 2 parts. Here's the first part. Just like we have in our formula over here that A is the first term, right? This formula has like its own little separate piece that just says term 1 equals A. So if we're going to write the formula, let's write that down here. We're going to write the recursive formula down here. So part A, we would write T1 equals, what's A? What's the first number? It's 2. So there you go. And then there's generally like a comma. We're kind of separating these 2 formulas apart, okay? Then it says, all right, Tn, any term, right? Tn could be any term equals Tn minus 1. Well, what's Tn minus 1? So this is any term, right? Tn minus 1 would be n minus 1. It's the term before, right? The previous term. So let's think about what that means. So for example, if you're on term 17, then 17 minus 1, this would be term 16, right? And then all it's saying is plus d, right? Plus the difference. So all it's saying is any term, it's actually a really simple formula, it's just confusing when you're first reading it. All it's saying is any term is equal to the previous term plus the difference, and our difference is 5, right? So there you go. If you want to find term 17, don't you just take the previous one and add 5? Look up at our pattern, right? Don't I take 2 and add 5 to get 7? Don't I take 7 and add 5 to get 12, right? So that's all this formula means. So if I write it looks like this. I write Tn equals Tn minus 1 plus 5. So there it is. Okay, so this formula is way less useful, but it's more about learning how to read it, okay? So if someone came along, we already know the first 4 terms of the sequence. We already know it's 2, 7, 12, and 17, but I want to just show you really quickly on this one, right? Someone says, all right, show how you can use the recursive formula to find the first 4 terms. Let me show you what that means. So we already know term 1 is 2, right? Check. There's the first one. Now how are we going to get term 2? Well, term 2 equals, right, any term equals the previous term plus 5. So term 2 equals term 1 plus 5. Well, what's term 1? 2. And what's 2 plus 5? 7. Right? And then what's term 3? Well, any term equals the previous term plus 5. So term 3 is term 2 plus 5. What did we just find term 2 was? It's 7, right? Let me highlight these here to make them a little clearer. There's term 1 equals 2. Term 2 equals 7. All right. So what's term 2? 7. What's 7 plus 5? 12. So it's more of a method of showing the pattern itself. All right. What's term 4? Term 4 equals term 3 plus 5. Well, we just figured out term 3 was 12, right? 12 plus 5 is 17. And we can do this all day, but there you go, right? There's the first 4 terms shown using the recursive formula. So in a minute, I'm going to give you a recursive formula, and then we're actually going to try and figure out what the first, terms would be, okay? Now, why do they call it recursion or recursive? Basically, a recursive formula is something that calls back on something previous, right? So notice how to get term 2, you had to call back and use term 1. To get term 3, you had to go back and use term 2, term 4, right? So there you go. It's reoccurring, right? All right, so let's do some examples here. All right, let's run through some examples. Example 1. Given this pattern here, the sequence, let's determine each of these things. All right, so the first part says determine the general term. That basically means find the formula, right? So let me just write down what was our general term formula, right? We have to know what A is. That's our first term. We have to know what D is. That's our differences. And the formula looks like this. Tn equals A plus n minus 1 times the difference. All right, so what do we know? The first term's easy to spot. It's 7. What's the difference each time, right? We are decreasing by 4, right? So let me just write that down. There we go. Okay, so that means D is negative 4. All right, so let's substitute those things into our formula and then simplify our formula, okay? All right, so Tn equals 7 plus n minus 1 times negative 4. All right, so 7 plus negative 4 times n is negative, oops, I guess I don't need the plus there anymore. Negative 4 times n is negative 4n, and negative 4 times negative 1 is positive 4. All right, let's clean it up. I'm just going to put the negative 4n at the front, and 7 plus 4 is 11. So there we go. Tn, which is the general term, equals negative 4 times the term number plus 11. So there is the general term formula, also generally just called the general term. There it is, because with that formula you can find any term, okay? Part B, write the recursive formula. We're not going to do anything with it, but let's just find it. So remember, the recursive formula looks like this. T1 equals A, and then Tn equals Tn minus 1 plus D. We're not going to do much with it. We're just going to write it down. Term 1 is 7, comma. Term n is any previous term, n minus 1, plus the difference, so plus negative 4, so we're just going to write minus 4. So that's your recursive formula. The less useful formula this time, but it's more about, in grade 11, just getting used to writing it and reading it so that we understand how it works. All right, part C, determine T25. Now, whenever I'm using this, I am not going to use the recursive formula. We're going to always use the general term. Only use the recursive formula if a question says use the recursive formula, okay? And there's only going to be a couple of those that pop up. And I'll say, this is the recursive formula, okay? So everything, like I said, like 9 out of 10 questions, you're using the general term. When in doubt, that's what you're using. Unless you see the words, use the recursive formula, okay? All right, so here we go. So find term 25. Well, here's our general term, right? Tn equals negative 4n plus 11. What we need to substitute in is 25 for n and 25 over here for n. Pretty simple, right? So this is just like the beginner example I did previously, right? So term 25, well, what's negative 4 times 25, right? It's going to be negative 100 plus 11 gives us negative 89. So if we kept going in this pattern and found the 25th number in it, it would be negative 89. There you go. All right, let's move on to the next example. Okay, so here's an example where we're going to use a recursive formula. The only thing I'm going to be asking you to do with the recursive formula is I'm going to give you a recursive formula, and I want to see if you can find the first however many terms. So this says find the first 4 terms in this. Okay, so let's go through this. Now, we already have term 1. They gave us term 1, right? So I'm going to write that right here. We got the first term. Term 1 is 3. Cool, check. All right, so I'm going to put a box around that, highlight it. There you go. Term 1 is 3. Let's do the next term. Term 2. This is where we look at the rest of the formula. For any term, right? Remember, this is any term, 2 times the previous term minus 1, right? So because if this is term 2, 2 minus 1 would be 1. So that's term 1. So what we're going to do is go 2 times the previous term minus 1. That's what this is right here. Okay, let me just erase this here. This right here is the previous term. All right, and that's what this part of this, learning these, is just learning to read the lingo. That's really what this is about, teaching you how this kind of recursive pattern works. So any term, whatever term you're on, we're on term 2, 2 times the previous term minus 1. All right, so what's the previous term? It's 3. There we go. So what's 2 times 3? 6. 6 minus 1 is 5. So there's term 2. And then it's just so on and so forth, right? Just continue the pattern. All right, what's term 3 going to be? Term 3, 2 times the previous term minus 1. What's the previous term? It's 5. 2 times 5 is 10. 10 minus 1, just jump to the answer, is 9. And the fourth term. 2 times the previous term, right, which is 9. Sub it in. 2 times 9 is 18. 18 minus 1 is 17. And there's the first 4 terms, right? We got them. 3, 5, 9, and 17. Let me just write them out here. 3, 5, 9, and 17. Now we could keep going, but it just wants the first 4 terms. Now part B, is this arithmetic or not? Well, let's have a look here, right? Here's term 1, term 2, term 3, term 4. What did it take to go from 3 to 5, right? What did we do? We added how much? We added 2. And then 5 to 9, we added 4. And then 9 to 17, we added 8. So there's definitely a pattern here. It's doubling, right? 2, 4, 8. The next one might be 16, right? But this is not arithmetic, right? So I didn't pick an arithmetic one here. I just picked kind of a made-up one here. It's not arithmetic, right? Because there's not a common difference, right? So because the differences are not common, okay? I'm just going to write diffs for short. Differences are not common. Remember, to be common, what we mean is, are you adding or subtracting by a common value each time? And we're not. Okay, so really what I'm testing with this is, hey, can you just find them? And then obviously, do you recognize if the pattern is or isn't arithmetic? Okay, so that one's not. All right, let's do just a couple more real quick. All right, so right off the bat on this one, it's not asking us to use the recursive formula, so I just want to be clear. Steer clear of that recursive formula other than like 1 or 2 questions here or there, okay? I hesitated to even cover it at all because I don't want to confuse you. A lot of people start using it in places it just doesn't apply. Everything is generally using the general term, unless it's the only thing I'm going to ask you again is, hey, here's a recursive formula. Can you find the first so many numbers in the pattern? And then is it arithmetic or not, okay? So everything we want the general term for. Now this is a great question, always on a test kind of question. Determine the number of terms that are in the sequence without, now again, there aren't very many, so you could figure it out just by, adding and counting them all up. But what if I made like, thousands in here, right? Then how many would there be? So what do we have here? Look, we got term 1 is 3, term 2 is 7, term 3 is 11, and then it gets all the way to term I don't know, right? Like what is this? That's what we're looking for. We're looking for n, right? So what we're trying to do here is that's the last number, right? So now some of you might just figure the pattern out and just count forever, but what we want to be able to do is do this with the formulas. What if it was a really big number? What if it was a million and something, right? So again, this is the last number in the sequence. Let me just get some clear, important stuff down. Last number, oops, here we go, sorry, in the sequence. Okay, so what we want to do is find its term number, right? So let's find its term number, which is n. All right, now if we can find that, that's how many numbers in the sequence. Like let's say it's term 500. That means there's 500 numbers in the sequence because it's the last number, right? All right, so let's do that. So let's start with what we know. We know A, and we can figure out D. A is 3. That's our first number, right? And the difference, what are we adding by each here? It looks like we're adding 4 each time. So D is positive 4. Okay, so we're adding 4 each time. Here we go. So what we're going to do is let's start with our general term formula, right? Let me just get this down here. All right, so it starts like this. Tn equals A plus n minus 1 times D. And let's sub in what we know. Right? We know A, we know D, so we can sub those in and simplify this, right? So A is 3, D is 4. All right, let's just clean this thing up. We got 3 plus 4 times n minus 4, which gives us 4n minus 1. All right, so we got our general formula. We need that, and you generally need that for most of these questions. That's kind of your first goal. Even when it doesn't tell you, other stuff or whatever, try to find that first. Okay. So now we got that, and what we want to do is figure out, well, how many terms are in this. So we've actually already done a question just like this. All we're going to do is we're going to set Tn equal to the last number, right? 127, and then just solve for n. That'll be its term number, right? So as long as we have the formula, we can do that kind of stuff. Okay, so let's just take this formula here. I'm going to set Tn here, right? The term itself, the general term, set it equal to 127. All right, and now we got to do solve for n. So what are we going to do to isolate n? We're going to go 127 plus 1 divided by 4, and there we go. And what do we end up getting? I think we get 32. Yep. All right, so 32. So the last term number is term 32. So if I was to come up here and fix this, finish it off, this would be term 32. So the last term is term 30. Last term is term 32. Therefore, there are 32 numbers in the sequence. Okay. All right, so we can move on to the last one, and that's the big one. It's the really important one in the sequence. All right, so everything's been pretty simple so far. The last one's going to be simple, but it's important, and it's really making sure you understand how to solve a system of equations. All right, final example is the big one on the test, right? When we usually have a test in class on this. Given 2 terms in the sequence, can I figure out another one? Now, the last part here is not really super important for most of the question. What we really need to focus in on is here. We're given the 15th term is 75, right? Let me just highlight this. The 15th term is 75, and the 30th term is 120, right? We use all that, and then we're going to figure out what term 40 is. Now, the real goal, the real secret is we need to find the general term, okay? So our real goal is to find Tn, which is our general term, right? That formula. How are we going to do that? We need A, and we need to find D. Those are the 2 things we need. Once we have that, we can just plug 40 into the formula and figure out what it is, right? So that's easy. This is like 5 seconds at the end of the question. Most of the question is figuring out what A and D are, okay? So now, what we're going to do, step 1 here, and it's going to seem longer than it is just because of how I'm writing everything out. We're going to set up 2 equations. So this is basically using we're going to use a system of equations when we have 2 equations and 2 unknowns, right? Because that's the thing. I don't know what A is and I don't know what D is. So 2 unknown variables. So let's set up 2 equations with what we do know. Okay. All right. So here we go. So let's start. Let me just write it down here. We know term 15 is 75, and we know that term 30 is 120. Now, what's our formula look like? I'm going to write the same formula for both. Tn equals A plus n minus 1 times D. Tn equals A plus n minus 1 times D. So what do we know? We know that term 15, if I replace the n with 15, that the term is 75. And if I replace the n with 30, we know the term is 120. So we can sub in what we know into this equation. So I know 75 equals A plus 15 minus 1. So I'm just going to subtract that right away. 15 minus 1 is 14 times D. And 120 equals A, which we don't know, plus 30 minus 1, which is 29, times D. Now know what we have here? Two equations and two unknowns, right? So now we don't know the A and we don't know the D. That's what we're looking for. But if we have two equations that involve information from this pattern, what we can do is use elimination or substitution. So I'm just going to solve using elimination because that's always the easiest in this case. So let me show you why. So I'm going to solve for D. It's always going to be easiest to solve for D using elimination. And let me prove it to you. All right, so put one of your equations on top and one of them on the bottom. Okay, so that just doesn't really matter. I guess I'll put the one with the bigger numbers on top. So I got 120 equals A plus 29 times D. And let's put the other one on the bottom. 75 equals A plus 14 times D. Now, why am I using elimination? Because look, when I subtract here, right, when I take the top equation and subtract the bottom equation, the A's are going to cancel, right? These are going to cancel out. So 120 minus 75 is 45, right? The A minus A is 0, so it's gone. 29 minus 14 gives me 15D. All right, now I just got to divide both sides by 15. We got an equation here, right? 45 equals 15D, and we get 3 is what D is. Cool. So we just found out a big piece of the information we needed. We needed to know what D is. Now we just got to go and figure out A. So let me just write that up here as my little collection, okay? We got, don't know what A is, but we do know D is 3. Let's find A now, okay? So next step, how are we going to do that? Pretty easy. We have two equations and we have D, so we can just sub this in. So substitute the value of D, right, into one of the two equations, okay? Into one of the equations to solve for A. So this is going back to the start of grade 10 and maybe even a little bit at the end of grade 9. It doesn't seem like it, but these are two linear equations, and we're just trying to figure out where that point of intersection is. We're solving for A and D instead of X and Y, right? Sub value of D into one of the equations and solve for A. All right, here we go. All right, so who do you want to sub it into? Well, we can either sub it into, here's the equation, here's the first one or the second one, right? I should have numbered them 1 and 2, but then it's going to mix up with my numbering here. So I'm just going to substitute D equals 3 into, I'll just take the first one. Oops. This guy, 75 equals A plus 14 times D. All right, so 75 equals A plus 14 times 3. So 75 equals A plus 42. You're going to subtract 42 from both sides, and you're going to get A equals 33. All right, so there's the other key piece of information. So this question's all about, can you set up a system of equations and solve? Not trial and error guessing. I want to see if you can set up a system of equations, solve for the two variables, okay? All right, now to finish it off, we can actually just answer the question, right? What was the real question in the end? The real question was this: what is T40, right? That's what we want. What is term 40? So to find term 40, oops, I skipped step 4, I guess. I don't know why I wrote 5 there. Step 4, well, to find term 40, why don't we set up our general term? Set up the general term. Remember, the general term is just Tn equals, right? That formula. All right, so here we go. Tn equals A plus n minus 1 times D. Because a question like this, instead of asking what's T40, you might just say what's the general term? What's A and D, right? So we need this first. So A is 33 plus n minus 1 times D, which is 3. Let's clean it up a little bit. I got 33 plus 3n minus 3. So that gives me Tn equals 3n plus 30. There we go. Now we can actually do step 5, which is let's find T40, right? And again, almost all the work was finding the equation. Now that we got that, we can figure out what T40 is. T40 is equal to 3 times 40 plus 30. Well, 3 times 40, 120 plus 30 is 150. Now again, if someone were just to submit their work and say, oh, I just found 150, and they didn't do any of the other work, that's not the point. The point of this question is to show that you can create a system of equations and solve it, right? That's really the point of this question. So to make this clear, a question like this should say, you know, given all this, blah, 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 solve using a system of equations. That's what we're really interested. Can you create that, okay? Find the answer at the end is very easy if you have the system, okay? All right, that's it for this lesson.